Okay, forces, question 4, part E. The swimmer's speed increases as she swims away from the boat. Explain why the swimmer has a top speed. Okay, so the speed increases as she swims away from the boat, but why do they have a top speed? It's worth 5 marks. So 1, 2, 3, 4, 5. And I'm looking here for clues. Well, the first clue is they've given me a force here, or forward thrust. So if I imagine my swimmer at the start, so when they first start swimming, this is my swimmer. I've got thrust this way and nothing else. So start, so mid, so after a little while what happens is my swimmer again, I'm going to assume their thrust is still the same, they're not tiring, okay, the thrust is there, but what's happening now is as they've got faster, this effect of drag or water resistance, okay, starts to increase. So drag or water resistance starts to increase, and as they get faster and faster, so start mid, and this is towards the end of the swim, what happens here, there's our swimmer again, they're not tiring at all, our swimmer, they're super fit, okay, this isn't a question about them getting tired. But what happens is their drag, as they get faster, their drag increases until their drag equals the thrust force. Their drag increases. Okay, so the first thing we need to say is as the swimmer starts swimming, so we've got 5 things to say. We've got to describe what happens here. And eventually these two equal each other. That equals that, and at that point you're at top speed. So it's an explain question why they've got a top speed. So you might start here by saying, actually, we know that that speed increasing, so the swimmer accelerates when forces are unbalanced. Okay, so we know why acceleration happens when the forces are unbalanced. At start, only thrust acts. Okay, right at the very start. So the forces are unbalanced, only the thrust is acting. Then what happens? As the swimmer gets faster, drag force increases in size, okay, and acts opposite way. One acts too slow. Okay, now my diagram hopefully will be enough to explain that as well. If I haven't worded it particularly well, then that's fine. So drag force is increasing in size and acts to slow her. Well, in fact, acts against her. Let's not say slow, because it actually doesn't necessarily slow her down. It stops her accelerating. Okay, and acts in opposite direction. Okay, so as drag force increases, acceleration decreases. Okay, so she's still getting faster, but she's getting faster by a smaller amount each time. Eventually, drag force equals thrust. Okay, that's a really big deal there. So there, at this point, forces are balanced. Forces are balanced. No resultant force, or resultant equals 0. Resultant force, constant speed. Okay, at that point there's no change. And we call that constant speed, so we call this constant speed. In fact, constant top speed, terminal velocity. And all vehicles that travel through a fluid, so through a solid or through a liquid or a gas, will experience that terminal velocity. Eventually, they'll get to a top speed. And the only way to overcome it is either to provide more thrust, so bigger engine, nitrous oxide, whatever it's going to be, or you can reduce the drag effect, which means make it more streamlined, more aerodynamic, or reduce friction. Okay, hope that was useful. Take care.